I'm again sorry for today, it also get disconnected. Okay, so as I'm mentioning that let me draw it again. So let me draw it now in a more convenient way. So these are, let's say, initial part where C6H5 COCl, and we have AlCl3 and hydrous. In every of the example which I give, try to do it by yourself. First, pause the video, do it by yourself. Like, doesn't matter you get it or you don't. Just try for 5 to 10 minutes. Go through the other lectures, go through the notes you have, go through AS notes, go through A2 notes. Okay, so far, revise the organic chemistry. Like, organic chemistry knows all the condition, what sort of reaction they undergo. Then, even if you don't get it, see the video. After observing the video, like, immediately do it first. Okay, immediately do it first. After doing it, then eventually, like, after, let's say, several hours, let's say 5 to 6 hours, like, let's say you are doing it in the morning, let's say in the afternoon or in the evening, do the same math or do the same structure. Let's say, draw it by yourself, keep the positions blank. Okay, uh, and or do one thing, that same question, like the question I'm like, let's say, for example, I'm giving this question CH3 CH2 Cl. Let me at first give the question, then let me explain. And hydrous condition, we would get something like this, from where if we add it, and let's say the condition, like, this is actually they have mentioned the I forgot to actually mention the molecular formula. So they have given you the formula, molecular formula. And over here, when we add, let's say, Br2 with sunlight, we tend to get this. And final reaction should be this. Let's say I have given you this question. Okay. Now, whenever I this sort of question, try to draw a two such sets. So draw the same thing or repeat the same thing, or take a screenshot. Like, in this situation, take a screenshot in this situation. Okay, like the unsolved situation, the initial questions situation. Take a screenshot of this picture. Okay, after taking the picture, like, save it, like, into like save it somewhere. Now, observing that question or observing that picture, try to solve it by yourself, that I've mentioned. For example, let's say you tried it by pausing the video, you couldn't find it, you saw the video, and immediately you try to answer the question by understanding what's like which reaction actually happening. I'm also like mentioning that which portion reaction is this one. For example, over here, this is actually free radical, sorry, this is actually electrophilic substitution, or our uh, Friedel-Crafts alkylation, which is actually the content for the first lecture of the organic chemistry, which is the first reaction of benzene reaction. And this is also Friedel-Crafts alkylation. And over here, we are actually getting free radical substitution. Free radical substitution meaning the contents from AS, where the reaction from our alkane, that's a characteristic reaction of alkane. So that's one of the reaction. Then we have KCN in ethanol, which is actually the reaction for halogen-alkane, and halogen-alkane we know undergoes our what sort of reaction it undergoes? It undergoes nucleo. Wait a minute. I tend to forget things. Okay, so halogen-alkane tends to be a nucleophilic substitution reaction. So this is a nucleophilic substitution reaction for halogen-alkane. You would also observe, like, find this on AS contents. Also, in the first lecture, I describe it very narrowly, but you would get in the AS contents. And here we have hydrolysis of our this reaction is actually a hydrolysis reaction. Okay, H plus in reflux. So this is actually a hydrolysis reaction, or a reduction reaction is actually happening. Sorry, not a reduction reaction. This is actually oxidation reaction. Yeah, oxidation reaction is happening. Okay, so whatever it is happening, um, This is actually hydrolysis, yeah, or hydrolysis. And like I was mentioning, like what I was saying is that take the screenshot you have, okay? So now you have solved it. After let's say 2 to 3 hours or 5 hours later, that same screenshot, like take it out, which was like unsolved one, and do it by yourself. Try to recall, like were you able to remember? Don't worry even if you can't find, or even if you can't understand, or if you have forgotten. Go back to the, let's say, the solved one, or just rewatch the video, understand the video one by one, step by step, like watch the video if required again and again, and then go through the materials. For example, the AS organic, like the portion I'm mentioning specifically, let's say if this is the portion for Friedel-Crafts alkyl, like sorry, this is the free radical substitution part, only revise that part, okay? Only revise the free radical substitutions part. If this is Friedel-Crafts alkylation, only revise the free radical, the Friedel-Crafts alkylation part. Obviously you will revise the whole note by yourself, like obviously you need to revise the whole note, but while solving this part, just go to that portion of the note, okay? Now after solving this, you solved it, then when new question I'm giving, also again do the same thing, but this time, like initially seeing the question and solving it by yourself. Try to have space. Now what do I mean by that? Let's say in the first day you saw the solution, okay? You saw the solution by observing the video, and immediately you attempted the answer, okay, without having any gap between the time, okay? Now let's say this continued, let's say for 2 to 3 days or a week. Now after, let's say 2 to 3 days or a week, whichever is preferable, have a gap of between, let's say half an hour or 15 minutes, or whichever is possible, like whichever is good for you. Then after a few days, have a space or difference, like have a gap of, let's say 1 hour, okay? Like initially you saw the video and then you solved it by yourself. Then have, let's say 2 hours. Then have almost, like then at last, like at the end, try to have at least almost equivalent to, like let's say a day, okay? That is what is actually making you having or helping you to grow your muscle memory. I'm not talking about the same question here, okay? In this case, it is a like different question, like in different situation, like it is actually building gap or in between, like the solving moment. Now after some time, also try to get back to the previous materials or previous questions which were given, okay? Try to solve those questions by yourself. If you don't get it, again watch the video. Don't worry, it's nothing, like there's no loss in like rewatching the videos, okay? Because there are more materials to be covered, like there are obviously many more questions to be solved, okay? So observing or having spoilers, it's completely fine. Spoilers as in like the spoilers of, let's say you are studying a new book, new storybook, or watching a movie, and some friend of you comes and say, yeah, this hero is going to get killed, or this villain is going to get killed, and like that's a spoiler alert. So don't worry about those spoilers, because eventually you will have more questions to solve. So in those moments, inshallah, you'll be good to go. So over here, as I mentioned, this is actually our anhydrous anhydrous condition LCl3, which this reagent is being provided. This is actually Friedel-Crafts alkylation. Now over here, also a Friedel-Crafts alkylation is being like presented, and from this Friedel-Crafts alkylation, we can see the next reaction is what? It is actually Br2 with sunlight, isn't it? Br2 with sunlight, that means a UV light is produced, and this is actually a side chain reaction, which is our free radical substitution. And this is actually occurring on the side of the like benzene ring. There's like no main reaction occurring, that's a side reaction happening. Now what could be then this product? Also observing this matter, like this molecular formula, we can see that actually we have how many carbons here? This is 6, and there's this 6 carbon. So in total we have what? 12 carbons, but here we have 3 more carbons. That means our structure should have like more 3 carbons present, isn't it? Carbon, oh, not 3, sorry, there is 6, there is 12, there's 13 13 carbon. There is also another carbon. So 6 plus 6, 12 plus 13. Yeah. So that means we need 2 more carbons. That means this is one carbon, that's another carbon. So that actually satisfies the situation. So let us first like draw the part. So far we have like covered. So let's say this is what we are assuming it should be. We are assuming that this should be the situation. Okay. Now, what about the bromine? Now, bromine does what? Free radical substitution means that portion, it actually tends to like replace the hydrogen, isn't it? Now, if I give another stand here, what would this represent? That means there is another carbon, but that's not the case, isn't it? There's no more carbon here. So far, we have this, but maybe on the like before this, like in the just the first part of this today's lecture, maybe I have given another stand here. That shouldn't be the case. I'm sorry for that. So there's the correction, I guess. It should be just two like carbon here. One is this one, and another is this one, and we don't need to show the hydrogen because hydrogen could be just like imaginary, and bromine is actually going to replace that hydrogen and be substituted in this place. Now this is our free radical substitution. Now in the next reaction, what is happening? KCl in ethanol. That means nucleophilic substitution is taking place, which is going to substitute this Br. This is the reaction, characteristic reaction for our halogen alkane. So this is going to be CN. Okay. Now after forming CN, we are observing that H plus with reflux. Now, yeah, it makes sense that actually this carboxylic acid will be formed from this CN. Okay. If we see reactions for nitrile compound in AS contents, there are contents for like reactions for nitrile compound, you will observe there that there are reactions where such reaction actually happens. Let me let me see it and then tell you the reaction of, wait a minute, nitrile compounds. Reaction of nitrile this is a nitrile compound. When we add this nitrile compound, yes, so it is actually acidic hydrolysis of a nitrile compound. Okay, so I have forgotten something. This is actually acidic hydrolysis. Acidic hydrolysis. Also, you can do one thing while solving. Do also write by yourself what sort of reaction is that, and where you can find the notes. So that, for example, you have seen like while mentioning tafsirs, they do quote like the portion from the Quran, so that like it helps you to identify, okay, from where actually it is. So for your next revision, this will be helpful for you from where to actually study. So acidic hydrolysis of nitrile compounds to make carboxylic acid. Okay, and these are actually contaminants from AS. You can write it in your way, like it doesn't need to be this much long. So whatever is suitable for you. And also remember, while you are writing this, it's actually like building your muscle memory. Okay, it's actually like developing your muscle memory, and also it also helps you to like recall your like revised notes. So that's also a like part of like, this is actually active like active revision is what it is, or active study. So this is what it is actually. So this is one of the example. Let's do just a few more examples so that we have, yeah, we can do 2 more examples. So let's say initially we have this benzene ring or benzene molecule. Okay, now we have added, let's say, CH3 2, then we have C, then CH2Cl. Okay, and sorry, there is a CH. It should be CH. Yeah, it should be CH. And yeah, now we are adding AlCl3 anhydrous. I miss always anhydrous and hydrous. And we have, let's say, this is the product. From there, CH3COCl, AlCl3 anhydrous. And from this product, which they didn't say, they just gave you the blank position for you to write, we added KCN, so that you have this product. This is another benzene. And we have this alcohol group, the cyanide group. This is, remember, this is also known as cyanide as well as nitrile. Okay. Now, from here, when we, let's say, add H plus with reflux, this H plus means it is in aqueous. So even if I don't write aqueous, always remember H plus only possible in like aqueous condition. It is actually possible. Okay. Then we have this compound, let's say. And from there, we have, let's say, concentrated H2SO4 with heat, or let's say conditions are, I need to write it in this way, concentration H2SO4 with heat, or we can have Al2O3. That means both the condition are possible, Al2O3 HEAT, and we get some product like this, let's say. CO2H. CO2H means actually COOH, okay, carboxylic acid. And from here, when we add, let's say, NiH2, I mean Ni with H2, okay, and heat, we get this as our final product. Okay, so let's try to solve it. At first, do it by yourself, try it by yourself, try to observe what are the conditions. You don't need to remember, like obviously you won't understand the products, but try to see what conditions have been provided and for which reaction the conditions are. Okay, like try to search your notes based on the condition, like okay, this is the condition for which reaction, this is the condition for which reaction, this is the condition for which reaction. Just remember that. Okay, now pause the video and try it by yourself, because I'm going to show it right now. So basically this first reaction, as we can observe, that this is actually what? Friedel-Crafts alkylation. Why? Because AlCl3 anhydrous situation. And over here, we're observing that these are the like molecule, like reagent being provided. And obviously in Friedel-Crafts alkylation, what happens? The chlorine or the bromine or whatever the halogen is, that gets eliminated. Okay, because we need to form a what? A electrophile, and electrophile will be formed by this one. So this is actually apart from our A2 is organic chemistry, benzene's first reaction. And after that, this is actually formed, and which is actually observable. Not necessarily, like you will see in the note, I have given the like alkyl over here, isn't it? Initially, it could be in any place. Obviously, they have given it here, but for our simplicity, we gave it on the top so that like we can count the number of carbons. That's what it is. In this situation, since this is over here, this is their number of, like this is their first carbon. Okay, this is the second, third carbon. So writing it in this way, it becomes complex, and there like the duty for of the examiners are to like confuse you. So that's why they have given you such a question. After that, they are adding CH3COCl AlCl3 anhydrous. That is also another like electrophilic substitution. I mean, Friedel-Crafts alkylation. From this product, we can observe that the next reaction, like since this is not given, we can try to take help from the next reaction, which is actually giving HCN in KCN, which causes this sort of product to be formed. Okay, that means what is being changed here? Can we observe? This was initially there. What is extra added? This portion. Okay, so that means something is going to get added to the end. This is initially there. This is actually this part. So they have drawn it now in a different way. Instead of here, they have like changed the position, but they have kept the thing same. So they added it over here, and see, this is the second carbon, that's the third, fourth carbon. So they have now further Friedel-Crafts alkylation happened in the fourth carbon. So here, and what should be our other components. Okay, so see this product, this product. What is it? If the chlorine gets eliminated, what will be left with? CH3COO. So that means CH3COO. This will be our yeah. So this will be our actual I mean product in this situation. Okay, so far is good. And when KCN in HCN is added, this reaction is actually based on our AS contents. This is the reaction for carbonyl compounds. So this is actually this is a ketone. So this ketone reacts with HCN in KCN. HCN is reagent, KCN is our catalyst. So it reacts in this situation for breaks the this is actually our nucleophilic addition, I guess. Wait a minute, let me see the characteristic reaction. Carbonyl compound, yeah, it is a nucleophilic addition. So nucleophilic addition is happening here. So after that, we're observing H plus in aqueous and reflux is happening. So this is what? This is a cyanide, and that is supposed to undergo this reaction, isn't it? So H plus in reflux, that means it is undergoing acidic hydrolysis, and that means a carboxylic acid is going to get formed here. And after this reaction, we can see, obviously we can take help from the forward reaction. So forward reaction, we can observe that these are the situation. So carboxylic acid, and here is now another ketone. So that means something is actually generating in between. Now what is it? This H plus, this hydrolysis is not going to react with this OH. Okay, no way this is going to have any reaction. So the only possible product so far is OH and COOH. Okay, and we'll be left with this one. And when concentrated sulfuric acid is added or heated with this portion, this component is tend to be formed. Okay, now what is this concentrated sulfuric acid doing here? So if we see from our S content, this is actually sort of, you can say, an oxidation reaction. So Al2O3 is an oxidizing agent. Also at times concentrated sulfuric acid, if we see the redox chapter from our AS contents, also from O levels, that concentrated sulfuric acid, it tends to act as an oxidizing agent. Okay, so this is actually, in this situation, it is acting as an oxidizing agent. Or Al2O3 could also be added. Same reaction would have been happened. That the alcohol being present here, this OH group present here, that is going to get converted into this is going to get oxidized to form a ketone group. And the forward reaction is what? This is nickel catalyst with hydrogen being added. So this reaction is known as hydrogenation. This is a reaction for this is hydrogenation. So this is actually reducing. This is a reduction reaction. This is causing this this ketone, sorry, there wasn't any oxygen. That's why I'm saying, how is this possible? This oxygen isn't here. I'm really sorry for that. There isn't this oxygen. So actually what is happening here, so let me think it again. There is this alcohol, there's this carboxylic acid. So this alcohol is going away. Okay, so this is actually a reduction reaction is happening, because yeah, so this is actually a reduction reaction happening. I'm really sorry. Over here, this is actually a reduction reaction. Just a minute, let me see it and say then. If we add Al2O3 in alcohol, what happens? Just give me a moment. Okay, so this is actually a dehydration reaction. I'm really sorry. These were previous content, so I forgot. So this is actually a dehydration reaction. Okay, so this is the opposite reaction. We can form alcohol from alkene. Okay, that is known as hydration reaction. These are also contents from AS. So you will observe, you will see that preparation of alcohol, you will get it there. And the reverse reaction is alkene from alcohol. Okay, that is known as dehydration. That means over here, water is actually added. That's what hydration means. And over here, water is taken away from you. So that's dehydration. So that's actually alkene, like alkene from alcohol. So here, if that's what is happening, this alcohol is being taken away from you. The conditions are there. This either of them would do fine. Concentrated sulfuric acid with heat or L2O3. You will find it also in the AS contents. There is like the reaction said as dehydration. So from alkene to alcohol, this is known as dehydration. Dehydration, and this is AS content. Also, you can write, like, obviously conditions are written here. So this is the dehydration part, and from here, this is actually hydrogenation. Now it makes sense that hydrogenation is the simply adding hydrogen to the alkene group. So alkene has what? Double bond. So this is sort of alkene. So when hydrogen is added with nickel catalyst, this one of the pi bond breaks and hydrogen gets added to this portion. So that's why the double bond disappeared. So this is a hydrogenation reaction. This is also, you will be able to find this also in, I think this will be able, you will be able to find it on O-level content. But yeah, like this is not a very like difficult condition to be remembered. So I guess you'll be able to remember this. But yeah, that's this example. And the next example, the last example for today is, let's say this sort of question also comes, which is, this is our, let's say, the initial molecule. Okay, so one more thing is left. Now, there are certain several conditions they have provided. This is, let's say, in one state, one of the experiment, they have excess Br2 is added. And another state, let's say, like this whole reaction, like this whole portion, let's say in one container, this is added with this, like this one. Then in another situation, NaBH4 is added with this one. And in another situation, let's say, excess or NaOH aqueous is added. Okay, so in which condition what will be produced? I would urge you to like go through the materials from AS contents, because is any one of them, yeah, some are from our A2 content, while some are from the AS content. So I would urge you to pause the video and do it by yourself. So basically what is happening here is excess Br2. That means this is actually what? A phenol group. This phenol group is going to react with this bromine. Is there anything else could that going to react with it? Obviously, there's this alkene group. So alkene also reacts with bromine. So that means our final product would be OH. There's this Br. There's this Br. Okay, so that means this is actually happening what? Our like identification of phenol, and this is actually undergoes like electrophilic electrophilic substitution. And like the mechanism are not given in our A2 notes, but yeah, that's actually happening in that way. And these are the other components. Over here, you would get one of the bromine over here, another bromine over here, and we'll be left over with this one. Okay, so this is actually one of the, like this is the product for the excess Br2 aqueous. Now when NaBH4 is added, what is happening here? This is actually, now if we also, like this is actually reaction from our AS content. If we tend to go back to, let's say, which portion was it? It was in so in this case, what would be like a possible situation could be, these are actually reduction. So reduction for the like this condition, it is a reducing agent. Okay, so what they're able to do is convert or like reduce this carbonyl groups. So these are carbonyl groups, this and this is the carbonyl group. Now can you guess this, what group is it? It is a ester linkage, isn't it? So there won't be any like difference in this ester group, or no alteration will be made here. But only thing would be this ketone, like this is a ketone, this is an aldehyde group, and this is also an this is also an aldehyde group. So yeah, both this aldehyde group will be converted into what? Alcohol. So we will be left with this OH. There will be no change with this our phenol group because it doesn't react with our NaBH4. So another reactions would be LaAlH4. So you'd see it in the preparation of alcohol chapter, like in the AS content preparation of alcohol. There is also given LiAlH4. Anyone would work fine. LiAlH4. So also in dry ether, so they also tend to give dry ether with in dry ether. So and that's another situation. So over there, this is ester linkage which does not have any effect, and this one will be formed alcohol, and the other things will remain same. Only this alcohol will be changed to this portion. So yes, that's our product for this NaBH4. Sodium, this is known as sodium tetrahydrobromate. Yeah, sodium tetrahydrobromate. So this is sodium, this is bromide, not bromide. This is tetrahydro. Sorry, I forgot the name. But this is actually boron. This is not bromine. This is boron, and this is for the tetra, like 4 hydrogen. And over here we have excess hot sodium hydroxide, which will cause actually to form this one, sodium hydroxide. So this one will react with this excess, obviously. I mean this aliphenol group. So that will be formed. And what else are we left with? We have this ester linkage. This ester linkage will break down because this is causing an alkaline hydrolysis for the ester group. Anything else? No, nothing else. So actually this will be formed. These are the products which will be formed. This is the O, and that's our sodium that will be formed here. Okay. So, and this is our alcohol. Alcohol will remain same, but for the carboxylic acid, part, that will be this one. Like this, if this breaks, this one will be now over here, which is ONA, yeah, and the other portion remains same, isn't it? Yeah. I'm sorry for such a messy drawing, but that's actually it. This is Na because in alkaline hydrolysis, what happens is like salt of the carboxylic acid is formed, okay, and the rest remains same. This is actually the acid group, where this is the carboxylic acid group. If you see it, like just try to observe it on the other way. Let's say if we draw it in this way, the other way, which will be, let's say, like rearranging the situation. This is our oxygen group. This is our Na. Sorry, not NS. This is our, there should be our O minus and Na plus. Okay. And over here we have this portion, and we have from here we have a double bond towards this portion, and from here we have, yes. So this is actually a situation. So you can try to draw it by yourself, this structure, and try to make yourself understand, okay, what is actually happening. Also, you can try to write the structural formula like in this way. This, let's say this is carbon. Okay, from here this is hydrogen. You can do it by yourself. You can try many different many different type of arrangement and observe it by yourself. You don't need to try it, like you don't need to think, okay, I have so much question papers to solve. Doesn't matter. Yeah, it matters question you're solving, but try to understand. Even if you understand one single question and solve it, that's far more better than solving like 10 question papers and understanding nothing. If you understand one of the question, do it by yourself. That's more than enough. Okay, so that's all for today. Next class we'll be continuing with more examples. Take care. Allah Hafiz. Assalamu alaikum.